Today we are looking at section 11.1, solving quadratic equations by taking square roots with complex number solutions. Let's get started. Let's start off with an introduction to imaginary numbers. An imaginary number is a number that doesn't fall on a real number line. We use the letter I to represent an imaginary number. I equals the square root of -1. Furthermore, I squared is equal to -1. I to the third is equal to I times I squared, which is I times -1, which is -I. I to the fourth is equal to I squared times I squared. I squared, as we know, is -1, and -1 times -1 is +1. I to the fourth equals +1. So with these rules, I only remember I equals the square root of -1 and I squared equals -1. So if there's a negative number under the radical, automatically that number counts as an imaginary number. Let's look at our first example. Find the square of the imaginary number. So we need to take the 5i and square it. 5i squared is equal to 5i times 5i. 5 times 5 is 25. And I times I is I squared. Based off of the rule that we learned earlier, I squared is equivalent to -1. 25 times -1 is -25. Which means that 5i squared is equal to -25. Now let's look at part B. We want to square -I times radical 2. -I times radical 2 squared is equivalent to -I radical 2 times -I radical 2. Let's multiply -I times -I. -I times -I is +I squared. And radical 2 times radical 2 is radical 4. I squared, as we know, is -1. Square root of 4 is 2. -1 times 2 is -2. So -I times radical 2 squared is equivalent to -2. Now that we got the hang of that, let's look at explain 4. Solve the quadratic equation by taking square roots. Allow for imaginary solutions. In problem A, we have x squared plus 12 equals 0. To solve this, I need to subtract 12 to both sides. That's going to give me x squared, and 12 minus 12 is 0, and 0 minus 12 is -12. Now we need to get rid of the square by taking the square root of both sides. The square and the square root will cancel out, leaving us with x equals plus or minus the square root of -12. Unfortunately, the square root of -12 is not a perfect square. So let's go ahead and break it apart. Let's do a side note. I have the -12. I know that the negative will turn into I, and the factors of 12 are 4 and 3. 3 is prime. Factors of 4 are 2 and 2, and the 2's are prime. So now let's put everything under the radical. We have the negative times 2 times 2 times 3. Once again, that negative, we need to pull that out. That's going to turn into I. And then also, when you're taking the square root of a number, you need to look for a pair of identical numbers. Here's our pair, 2 times 2. 2 times 2 is 4, and the square root of 4 is 2. That's going to go outside. What we're left with inside is the 3. So now we know that the square root of negative 12 is equivalent to 2i radical 3. With that in mind, let's go back to our problem and replace the square root of negative 12. So x equals plus or minus, like we said earlier, the square root of negative 12 is 2i radical 3. And that's our solution. Now let's look at part B. In part B, I want to subtract 11 to both sides. Now I have 4x squared, 11 minus 11 is 0, is equal to 6 minus 11, which is negative 5. Next, I need to divide both sides by 4, which leaves us with x squared is equal to negative 5 over 4. Let's get rid of the square root both sides. X equals plus or minus the square root of negative 5 over the square root of 4. So that's x is equal to plus or minus. We have the negative under the radical. Remember that negative turns into I, so let's go ahead and pull it outside. Radical 5, I radical 5. And the square root of 4 is 2. So our final solution is x equals plus or minus I radical 5 over 2. Let's move on and do another problem. Solve the quadratic equation by taking square roots and allow for imaginary solutions. In part A, we have 1/4 x squared plus 9 equals 0. Let's start off by subtracting 9 to both sides. That's going to give us 1/4 x squared is equal to negative 9. Now we need to get rid of the 1/4, so I'll go ahead and multiply both sides by the reciprocal of 1/4. The reciprocal of 1/4 is 4, and I'm multiplying by the reciprocal because 1/4 is a fraction. So the 4 and the 1/4 will cancel each other out, leaving us with x squared equals negative 9 times 4 is negative 36. Now let's take the square root of both sides. X equals plus or minus. We have the negative that's under the radical. Remember that negative automatically turns into I, and that negative is going to go outside. The square root of 36 is 6. We have I 6. This looks a little strange, so let's go ahead and rewrite it as plus or minus 6I. Moving on to part B. Part B is negative 5x squared plus 3 equals 10. Start the problem by subtracting 3 to both sides. Now we have negative 5x squared is equal to 10 minus 3, which is 7. Divide both sides by negative 5. That's x squared equals 7 over negative 5. Whenever I have a negative in the denominator, I like to move that negative to the top, so that I have x squared equals negative 7 over 5. That's just by preference. It makes negative numbers easier to work with if the negative is at the top. Now let's get rid of the square by taking the square root of both sides. So the square and the radical will cancel each other out, which will leave us with x equals plus or minus the square root of negative 7 over the square root of 5. We have the negative under the radical. Remember class, that's going to turn into I. So x equals plus or minus I. And we can't take the square root of 7 because it's not a perfect square, so we'll leave it as the square root of 7 over the square root of 5. Now we have another problem, and that problem is the radical in the denominator. As you know, you can't have a radical in the denominator. So let's go ahead and get rid of that radical by rationalizing the denominator. So let's multiply the fraction by whatever's in the denominator, and that's radical 5. So now we multiply straight across. X equals plus or minus I. Radical 7 times radical 5 is radical 35. And radical 5 times radical 5 is radical 25. And so our answer is x equals plus or minus I radical 35 over the square root of 25 is 5. And that concludes our lesson. If you like this video, go ahead and give it a thumbs up and don't forget to subscribe.